Hello, ma'am. Can I be able?
Yes, sir. Your voice is audible and your PPT is visible. Please continue.
Thank you, ma'am. It's my pleasure to take participant in 6th International Conference on Recent Trends in Multidisciplinary Research. Of my paper title is Automation of Drowsiness Alert System for Driver in Motor Vehicles in Bangladesh. My co-author is Muhammad Al Amin, Nijamuddin, Yamuddin, and Rakibul Islam. I'm currently graduated from East West University, Dhaka, Bangladesh. So my topic agenda will be today will be this. So one of the major causes of road accident is the drowsiness of people all over the world, especially in Bangladesh, where many deaths and fatalities occurs on the road due to this disregarded for traffic laws. Drowsiness detections and this paper focused on low-cost real-time drivers drowsiness detection by fusing facial image information obtained through the IR sensor and LiDAR sensor. So drowsiness is a major global cause of road accidents, notably impacting in Bangladesh. Careless driver, ignorance of traffic laws, and the rapid growth of automobiles contribute to this problem. Swift accident detection is crucial to minimize grief for victims and their families. Utilizing a microcontroller system integrated with IR and LiDAR sensor, we proposed a model to avoid drowsiness of the driver. So irresponsible and reckless driving influenced by unhealthy sleep routines and drinking habits contribute significantly in road accidents severely. Um, in a research 2017, 91,000 accidents and 50,000 injuries were attributed to drunk driving. According to Buet Accident Research Center, 12,000 lives are claimed and 35,000 injuries occurs annually in Bangladesh due to road accidents, and around 45% are caused by drowsiness. And if we think about global perspective, worldwide 500,000 people die and 10 to 15 million are injured in road accidents annually. So here we can see that annual reported in road accidents in Bangladesh, where different kinds of motor vehicles are caused and in road accident. So related work, drowsiness detection system development began in the 1990s with Hiroshi Uno, his team focusing on image-based detection. GSM enabled accident alert system is another way of drowsiness alert system. So Amin et al. Author enhanced a smart vehicle system using GSM networks to send accident alerts to a predetermined phone number. But here, this system has a flaw, triggering false SMS alert during severe traffic jams. Another company, renowned company, Volkswagen's driver drowsiness detection. Here, both drivers with drowsiness detection systems uses the steering angle sensor. So project of our goal was aimed to develop a sleepiness detection system simulation, creating a system focusing on identifying a tiredness by monitoring closed eyelids, face movements, and with this early key signs, we can detect the drowsiness of any driver. So in our proposed solution, microcontrol processor take the input from the IR sensor and the LiDAR sensor. By analyzing those input, microcontrol processor um, take over and give the alarm to the driver, and driver can take over control, and then further needed action will be taken by the driver. So in proposed solution, we here we see that IR sensor where the threshold time was 3 seconds, and the LiDAR sensor, the angle of the face threshold angle was 60 degree. By this input, we can verify the condition of the drowsiness of any driver. Then the alarm will be taken charge to inform the driver to take necessary response for avoiding the accident. So in our system features, we affordability and accessibility, we here the project prioritize cost effectiveness to ensure the widespreadness adoption of the drowsiness detection system by utilizing cost-effective technologies like IR and LiDAR. And the focus is on making the solution accessible to a broad range of vehicles and drivers. LiDAR to calculate face angle, threshold face angle will be 60 degree, and there will be a buzzer and a vibrator. System components, here we can see the LiDAR components and the IR sensor here. Then the system operations in our project will be drowsiness detection. The system continuously monitors the drivers for signs of the drowsiness using an IR sensor, and alert generation upon detecting drowsiness. The system activates an alarm to alert the driver. Driver response, the system allows a brief window for the driver to respond to the alert and take corrective action. Takeover, if the driver fails to respond within the specified time, the system initiates an auto takeover. Auto takeover action involves implementing safety measures like slowing down the vehicle or activating hazard lights, etc. Additionally, the system may communicate with external systems such as IoT devices to notify relevant authorities about the driver. But our proposed model is not considered this because we only focus the initial point of this project. Limitation we can see, and the boundaries only show the drowsiness detection along with the alarm for awakening the drivers, and takeover action if the driver response is not initiated after the drowsiness detection. Auto takeover process can be further concerned. But after takeover, further execution process will be the field where many more work for the safety of the motor vehicle can be taken place. In future works, we can suggest the potential for the futures integration with Internet of Things for accident investigations and transport reporting. Challenges in accident investigation, we can see the challenge of the reason behind the accidents by the accident creating transparent accident. Sorry. And real-time data for law enforcement. By implementing this project, we can store data and envisions using project data for real-time communication with the nearest police, especially when driver signals drowsiness alerts. So in conclusion, we can conclude that the significance of drowsiness in nowadays severely matter to consideration on automation. And we had think about the simple availability of local market of this instrument, which is LiDAR and IR sensor, and we can collect those easily by the local market. Also, we see that the system's working also in the day and night light. Through the project, the scope for more development in addition with the take cover mode, but the proposed model will cover the significant action which prevent the significant percent of cause of road accident by drowsiness. Thank you so much. If any question.
Hi, Mr. Nahid. It was a very social related concept, really appreciable to get into this kind of research. I would like to ask you that in your system, this proposed system can be utilized in all the kind of vehicles, or it has some limitation, or it can be used in a specified vehicles only?
Our proposed model can use any kind of motor vehicles, but it convenience with three-wheeler or four-wheeler, it would be more convenient, because two-wheeler motor vehicles is not so sophisticated to fixed and implement the elements. So we see that the three-wheeler and four-wheeler motor vehicles is more convenient.
Okay, and also you have told in one of your slides that the system will take over if the driver is not alert after giving the alert, then the vehicle will slow down. How is it? Can you explain this?
Our proposed in this proposed model, we limit. There is a limitation. Takeover will not in our takeover will not place in our proposed model. But in future works, we can see that, like when the lane is violated by the motor vehicle, or the when the alarm is continuously alarming, but the driver not responding, that time extra action will be taken, and which is not given in our project model. That will be placed in the future works.
Okay, thank you very much, Mr. Nahid. All the best wishes for your future work.
Thank you. It's a pleasure. Thank you.